Welcome to Hartman Math. This is lesson 6.1, function composition. Before we get to the composition part, just some other operations that we can do with functions that we've done with polynomial expressions before. Example number 1, we've got f of x, we've got g of x. We can add the two functions, like we would add the two expressions. So that would be 3x minus 2 plus x minus 7. We've seen this before where you don't really need the parentheses in this case. So if we just 3x plus x is 4x, negative 2 plus 7 is positive 5. We get our answer of 4x plus 5. We can just combine like terms. Part B, subtract. So f of x minus g of x. This time, though, we will need to distribute the minus, or you can think of this as a negative 1 times both of these things. 3x minus x is 2x. Negative 2 minus 7 is negative 9. We can multiply two functions, 3x minus 2 times x minus 7, distribute the 3x. So 3x squared plus 21x, distribute the negative 2. Negative 2x minus 14, add straight down in columns, and we've got our product. D, f of x divided by g of x. Now, unlike back in chapter 5, we're not actually going to need to perform the division. We'll just need to show it as a fraction like it is here. So that would be 3x minus 2 over x plus 7. But division comes with one extra condition because we're not allowed to divide by 0. Here we're dividing by x plus 7. So we would say x plus 7 cannot equal 0. And then we want to solve for x to find out what x cannot be for that quotient function. So x cannot equal negative 7. So that's true of any division problem. You really got to take a look at the domain, which is coming from the denominator since we're not allowed to divide by 0. So notice, denominator cannot equal 0, and go from there. All right, so here's part E. Here's the composition, f of g of x. So it's just larger scale substitution. First thing we're going to do is we're going to replace the inner function. G of x is x plus 7. So replace this with x plus 7. We're going to take the x plus 7 and plug it into the f function. So the f function was 3 times x minus 2. Wherever there's an x, we're going to replace it with this. So 3 times this minus 2. So we replaced x with our input of x plus 7. Let's go ahead and simplify, distribute. Combine like terms. There's our composite function. We can switch it around. G of f of x. So once again, we'll start on the inner function. We're going to replace f of x with 3x minus 2. Then we're going to take that and substitute into g. Starts with x, so throw away the x, replace it with this. Probably still want to use the parentheses. Plus 7. So now we can just combine like terms, 3x plus 5 being our answer. Example 1, part G, you can compose a function with itself, f of x. So again, same rules. Start with the inner function, replace f of x here with 3x minus 2. Now we're going to take that, plug it into the f function, which is here. Starts with a 3. Throw away the x, replace it with minus 2. Distribute, combine like terms. All right, go ahead and try these. We've got a quotient function and a composite function. Pause here until you're ready. So the first part of the quotient function, that's easy. We just got to put f of x on top, g of x on the bottom. There's our quotient function. But it does come with the condition that for the domain, you can't divide by 0. So we have to say 5x plus 1 cannot equal 0. Solve that for x. Minus 1 both sides. Divide by 5 on both sides. X cannot equal negative 1/5. Part B, f of g of x. Start on the inner function. Replace g of x with 5x plus 1. That substitutes into the f function, which is here. Starts with a 2. Then there's the x. Throw away x. Replace it with 5x plus 1. Minus 5. Distribute. Combine like terms. Example 2, part A, again focusing on the composition. F composed with g of x. Start on the inside. G of x gets replaced with 2x minus 6. That's going to get plugged into the f function. So it starts with an x, throw away x. It gets replaced with 2x minus 6, and it is supposed to be squared. Plus 2 times, throw away that x as well. All x's get thrown away, and they get replaced by our input, 2x minus 6, minus 3. So you may want to pause here and do this kind of over on the side. Remember, we're not allowed to distribute an exponent over subtraction. We have to do 2x minus 6 times 2x minus 6 and multiply that all out. We would get this is supposed to be 24x right there. And distributing the 2, 4x minus 12 minus 3. Four x squared minus 20x plus 21. Part B, we don't always have to do it at x. We could do g of f of 4. So we would start on the inside and find out, hey, what is f of 4? So up here, plug in a 4, see what you get. 4 squared plus 2 times 4 plus minus 3. And you get 21. Now we take that, plug it into g. So that goes here, 2 times 21 minus 6. And you get 36. Let's finish up with a u-try. Pause here. Find g of f of x. Resume when you're ready. F of x is the inner function, so we're going to replace that with x squared plus 2x minus 3. That gets plugged into G, so it starts with a 2. Then we got x, throw away the x, replace it with this, minus 6. Distribute to all, combine like terms, answer. All right, one last one here. Go ahead and try f of negative 2. Pause here. All right, we're going to start by plugging negative 2 into f. So negative 2 squared plus 2 times negative 2 minus 3. You would get negative 3. Plug that into the same function, into f. So negative 3 squared plus 2 times negative 3 minus 3. You get 0. So 0, final answer. That's it for today. I'll see you next time.